So assignment related to the fluid dynamics or fluids, and we have discussed in the last session. We discussed one question from this. So we finished till question 17. The question 18 and onwards. So in question 18 also we did. So we'll move with question 19. Yeah. Question 19. So the manufacture of a glassware requires a high temperature. Hot glass can be drawn into thin strand to be used in optical fibers. Explain in terms of the properties of the glass why this technique requires a high temperature. So what we have to do, like example, we have the glass, we have to supply heat energy so that we can convert this into a strand or to make an optical fiber. So why we need a high temperature for this? The reason is that like when we increase the temperature, the viscosity decreases, like substance can flow. As a result, when the viscosity decreases or it becomes less viscous, so as a result, we can easily deform or it can undergo a deformation easily. But at low temperature, the glass is a brittle material. Brittle material means like it cannot deform easily. So when we increase the temperature, the viscosity means property of a fluid to resist the flow. When a fluid cannot flow easily, that property of a fluid which does not allow it to flow easily, we call that as viscosity. So when for glass, what happened when because normally for a liquids, when we supply heat energy, its viscosity increases. For gases, the viscosity increases with temperature. So when we increase the temperature, the viscosity of the glass decrease. So it can flow easily or deform plastically. Plastic deformation means like object can undergo a greater deformation without breaking. That's called a plastic deformation. So when we increase the temperature of the glass, the particles, their force of attraction become weaker, so it can flow easily and it can undergo a plastic deformation. But at low temperature, why we cannot do this at a low temperature? At low temperature, glass is actually brittle. The term brittle means like object can break down with no or very small plastic deformation. So the marking points here, when we increase the temperature, viscosity decrease, that's one mark. Viscosity of a glass decrease and it can undergo or can flow or deform plastically, that's a second mark. And the third mark, at low temperature, the glass is brittle, means it can not deform easily or it can break down without deforming. So these are the points you have to include. The technique of a glass blowing allow hot gases to be manipulated into a variety of shape. The shape shown shows the graph shows a variation of the viscosity with temperature. Explain why high temperature required for this technique. Using a graph, now you have to say. Previously, like it was without graph, and now you have to use a graph to explain why we need a high temperature. So what is the relation? As you can see, when we are increasing a temperature, say at in the beginning, at low temperature, the viscosity is high. And the graph shows that the viscosity and the temperature are inversely proportional because it's a curve. So same idea, it's a similar answer that just you have to mention with reference to a graph as it's a curve and shows that increase in temperature, when the temperature increase, the viscosity will decrease. And when the viscosity decreases, the substance can flow easily, so we can deform or we can shape the glass. In question 20, this is a multiple choice question. The bubble move upward through a fluid at a steady speed. Steady speed means moving at a constant speed. So whenever object is moving at a constant speed, means there is no resultant force, or we can also say that the upward force is equals to the downward force. So the upthrust which is acting up is equals to downward force, which is the weight plus the drag. So the equation in which we have upthrust is equals to weight plus drag, or it can be other way around. Like example, so this one, as a result, should be zero. Whenever object is moving with a constant speed, there is no resultant force. Upward force equals to downward force. So either like W plus D minus upthrust, like we can say weight plus drag minus upthrust is equals to zero, or we can also say upthrust minus weight plus drag is also equal to zero. So either the two forces you mention equal or their result is zero. So here, why the first one is incorrect? Because weight plus drag is equals to upthrust. That's why this is not correct. This one, weight plus upthrust, that's wrong. It's weight plus drag is equals to upthrust. Here, weight plus drag minus upthrust. Like when we sum the upward force and subtract the downward force, the result should be zero. Like there should be no resultant force. That's why option C is the right answer. The flow of water in the pipe is turbulent. Which statement correctly describe the turbulent flow? So what happened in a turbulent flow? The particles are moving randomly. They change the direction. They're even in a series of the particle, like group of particles in the line, they are moving at a different speeds. They don't have the same speeds. So speed and direction at any point remain constant. That is not correct. That's the laminar flow. The layers are parallel to each other. Again, that's wrong. Like example, this is one layer, this is another layer. In a laminar flow, the layers are parallel. But in a turbulent flow, what happens? The group, or even within the layer, the particle does not move in a straight line. It changes their direction. The layer do not mix. That is again a laminar. And there are certain change in speed and direction. That's true. So in a turbulent flow, the particle suddenly changes the speed. Like say this particle is moving at a speed of 4 meters per second. The next particle which was following suddenly changes the speed or may change the direction to 5 meters per second or to 2 meters per second. Either increase or decrease can both happen. So speed and direction are not same in a turbulent flow for a group of particles. But at a specific point, speed is constant. In question 22, the magma consists of a molten rock and a gas, and it's found beneath the surface of the earth. During a volcanic eruption, the magma rises to a surface and pours through an opening of the earth crust. As the magma rises, the pressure decreases and the bubble of the gas expand and rise through a magma. Explain why the bubble rises faster through magma as they start to expand. So again, you have to use the concept of the viscosity, the drag. So as I mentioned here, like example, so this is a magma. And they mention here that during a volcanic eruption, as the magma rises to a surface and it poured through an opening of the earth crust, as the magma rises, the pressure decreases and the gas bubbles expand and rise through a magma. Like there's a gas bubble, but as the pressure decreases, this gas bubble start to rise in the magma. We have to explain why. So as the pressure is decreasing, the volume of the gas will increase. And we know the upthrust is equals to density of the fluid, volume of object, and gravity. So as you can see in the question, they already mentioned the bubble of gas expand. So as it expands, its size increases, volume increase. So if the volume increase, what happened to upthrust? The upthrust will also increase. So when the volume increase, the upthrust depends on density of a fluid, volume of object, and gravity. So if the volume increase, the upthrust will increase. And the forces, what are the forces as it is moving through a magma? The upward force will be the upthrust. There will be a weight of this bubble, and there will be a viscous drag or a drag force as it is moving. So when the upthrust increase, this upthrust is more than the weight and the viscous drag. That's why it will accelerate upward. So points which you will mention. So the upthrust depends on the density and the volume of the object. Density of the, and it's not like, it's basically the volume of the displaced liquid, how much it will displace a liquid. So if the object volume increase, it will displace more liquid, so upthrust will be higher. So as a result, when the volume increase, the upthrust will also increase. And the upward force, like the upthrust is more than the weight and the drag. When the two forces, like upthrust is more than the weight and the drag, as a result, what will happen? The bubble will accelerate, or there's a resultant force on the bubble. As a result of this resultant force, it will accelerate upward. The table shows three type of magma. One is basaltic magma. Another one is their andesitic magma, which is medium viscosity. And the third one is their the rhyolitic magma, which is having a high viscosity. Explain through which magma the bubble will rise with a greater velocity. So which magma it will rise or move with a greater velocity? The one which is having a low viscosity, because viscosity, if a fluid is more viscous, it means there will be strong force between the particles within the fluid, and it does not flow easily, or it does not allow any object to flow through it. So two things, both things are there. When a viscous medium is there, it cannot flow by itself easily. And the second thing, it does not allow any material to flow through it. So in a basaltic magma, because it's having a low viscosity, as a result, when it has low viscosity, the bubble can easily rise or move. And why it will rise? Because what is the effect of the viscosity? According to Stokes, that the viscous drag is equals to 6 pi eta R and V. So it depends on the viscosity of a medium. So if the viscosity of the medium is high, the viscous drag will be more. If viscous drag is more, the object can slow down easily, cannot move. But in a basaltic magma, as it's having a low viscosity, so as a result, there will be low viscous drag, so the bubble can easily accelerate upward. The magma cools as it reaches the surface of the earth. How cooling affects the magma. So what is the relation between temperature and the viscosity? The temperature and viscosity are inversely proportional for a liquid. So when the temperature increase or the temperature decrease, its viscosity will increase. It will become more viscous. You just have to mention it, viscosity increases. A small stone of a mass m is dropped into a pond and it accelerates downward with an acceleration of a. The free body, so it means it's accelerating downward. That's the direction of the motion. So if accelerating downward means the downward force more than upward force. So means mg minus the upthrust plus the drag, which is upward force, is equals to ma. Or we can say like upward force minus downward force or downward force minus upward force is equals to the resultant force. So it cannot be A or C because there is a resultant force. So it cannot be A because A and C are only valid that if an object is moving at a steady or a constant speed. But in this question, it is accelerating. And when it is accelerating downward, the greater force is mg. So it will be mg minus upthrust minus drag is equals to ma. So it matches with option D. Why we did not select option B? Because in option B, upthrust, if it was moving up, accelerating upward, then it will be, and if it is accelerating upward, the drag force will be downward. But why we did not select B? Because it's up thrust plus drag minus mg, but the greater force is not up thrust plus drag, like it's accelerating downward, so greater force is mg. That's why it's greater minus smaller equals to the resultant force. The rate of a flow of blood through the arteries in human body depends on the viscosity of a blood. Sketch on the axes below the possible graph to show how rate of flow of a blood vary with viscosity. Like how the variation happen, how the blood will flow. As the viscosity increase, the rate of flow will decrease. Here, because you don't know whether they are linear relation or a non-linear relation, so both are acceptable. If the viscosity, and it should start with the maximum value of the viscosity. There is no viscosity for a medium, then it will have the highest rate of flow. Then as the viscosity increase, the rate of the flow will decrease. So you can draw a curve, as you don't know whether it's a, because you don't have the equation for that. So it might be a non-linear relation, so it will be a curve, or it might be a linear relation, so it might be a straight line. So both are acceptable, which shows that the rate of the flow is decreasing, or as the viscosity increase, the fluid become more viscous, it cannot flow easily. When the temperature of a blood is reduced, the heart has to do more work in order to pump the blood through the arteries. In terms of viscosity, explain. So what actually happen as a temperature decrease, the viscosity of a blood, like blood become more viscous. So as the fluid become more viscous, it will have greater friction force or greater drag. So we need a greater, so heart has to pump with a greater force. And if the force increases, the work done will also increase. The first thing, what is the relation between temperature and viscosity? As the temperature reduces, the viscosity will increase. That's one point you will mention, the relation between them. As the viscosity increases, what happened? The drag force or a viscous drag increases. So when drag force or viscous drag increase, then heart has to apply more force to pump the blood to a same distance. So if the force increase, the work done will also increase. That's why the heart has to do more work done in order to pump the blood through the arteries. In question 25, a student investigated the motion of a small sphere which is falling through oil. The sphere was released at the top of a cylinder which is containing oil. Measurements were taken to enable student to find the terminal speed. Terminal speed means the constant speed when the object is moving through a fluid. Describe the apparatus the student should use and the measurements to be taken. Student does not have access to the motion sensor or a data logger. You may include a diagram and in your answer. So whenever option is there, like you may include, then you should include a diagram so that you can mention like the points clearly. So what actually, because we want to determine the terminal speed. So we can take like, and a measuring cylinder is there, and we place two rubber bands, and it is filled with the oil. And on the measuring cylinder, first it is filled with an oil. and we place two rubber bands to determine the terminal speed or the constant speed. The rubber band should not be there near the top. It should be like from the center or midway, like closer to the center. So using a meter rule or a meter scale will determine this distance. And using a stopwatch will determine the time. Like we drop the sphere, and remember one thing, because we have to apply the Stokes law here. So the size of the sphere should be small as compared to size of the container. So it should appear as a small object. If you draw an object such as in this manner, then it means it is wrong. You cannot apply the Stokes law. According to Stokes law, the fluid flow should be laminar and the object which should be very small compared to size of the container. So for a small sphere, when the sphere is small and it moves through the fluid, like example, when you drop, it will move through this fluid. So the moment it crosses the first marker, we'll start the timer. And when it crosses the second marker, we'll stop the timer. So that is actually the time it will take to, like here at this point, when it reaches the first marker, we'll start and then we'll stop the timer. So using a stopwatch will determine how much time it will take to fall. So to determine the speed, because the terminal speed, we don't use equation of motion. As a terminal speed, there's no acceleration. So speed is equals to distance divided by time. So distance, how we measure? By using a meter rule or a meter scale, and a time by a stopwatch. So we will place markers in between, like from top to bottom. Then we measure a distance between the markers. We can use like a meter rule here. That is, then we record the time it take to cross from one marker to another by using a stopwatch. And then we'll repeat the experiment and work out the terminal speed by using a formula: speed is distance over time. Or we can also sketch a graph and then distance divided by time using a slope. We can work out, or we can change the distance between the markers and repeat the experiment and plot a graph between distance and time to the gradient represent the speed at which the sphere is moving. In part B, the teacher demonstrates the motion of a small sphere through a vacuum and in oil. You can see in a vacuum, it's a velocity time graph. So in a vacuum, what happened? The velocity is increasing, slope represents the acceleration. So in a vacuum, the acceleration is constant. But in oil, the acceleration decreases and eventually there is no acceleration or it moves with the terminal speed. The teacher used a motion sensor and a data logger connected to a computer. The computer plotted graphs for velocity against the time for the sphere as shown. And it's a 6-mark question, but the answer is very simple, like it's not difficult. Whenever a graph is there, always try to figure out what the graph is giving you, either what slope giving you, which quantity, or the area of the graph. So explain the differences between the shapes of the graph. So how the two graphs are different from each other, that we have to mention. So first thing, in a vacuum, first thing, the speed time graph, the slope represent the acceleration. So in a vacuum, it's a straight line. It means acceleration is constant. Where in a oil, it get curved and then horizontal. It means the acceleration is not constant. First, the acceleration decreases and then there's no acceleration. It's a terminal speed. Then in a vacuum, the forces which will act, that will be only weight. There is no air resistance. But in oil, what will happen? There will be forces like upthrust and drag as well. And always a constant force in a vacuum, which is causing an constant acceleration. But in a viscous drag, the resultant force, it decreases and eventually there is no resultant force and it will move at a constant speed, which is the terminal speed. So points here, in vacuum, the acceleration is constant. In oil, acceleration is decrease first, then 0. Like there's no acceleration. So these are 2 points, 2 marks. The next one, in vacuum, only weight is acting. But in oil, the two forces which are acting, that is the drag force and the upthrust. So these are like 4 points, 4 marks. Then in vacuum, what will happen? The resultant force does not change. When in oil, what will happen? The resultant force decreases. And eventually, the weight which is acting downward plus, because weight, as it is moving through the oil, so weight is acting downward, upthrust and drag are acting upward. So eventually weight is equals to upthrust plus the drag. So no resultant force or acceleration, or it move with a constant speed. So these are the points you have to mention, comparing the speed of the sphere, which is falling, one through a vacuum, another one is through the oil. The table tennis ball is held underwater. When the ball is released, it rises to a surface. Why? Like example, say we have a container which is filled with water, and there is a table tennis ball here which is held underwater. Like here we kept a table tennis ball. Then what happened? The moment we release this ball, it will move upward. We have to explain this observation, like why this happened. So basically, why the moment because we were keeping it underwater, but the moment we release, there's the upthrust, the force acting upthrust is equals to weight, and the moment we release, the upthrust is more than the weight. That's why it is accelerating upward. Or weight plus the drag, because that's why it is accelerating. Otherwise, if the upthrust was equal to the weight, it will remain at its position, like, because there will be no resultant force. So when submerged, like when we completely submerge this, there will be upthrust. The upthrust is a equal depending on the density of the fluid and volume of the liquid displaced. And the upthrust is more than the weight, that is causing an upward acceleration. So one point you will mention that the upthrust will be more than the weight, that is, or upthrust is more than the weight plus drag, both you can mention, that it create an upward resultant force, cause an upward acceleration or accelerate upward. And upthrust is equals, depends on the weight of the fluid or the liquid displaced. Viscosity of a paint determine how smoothly or easily the paint can apply. If the viscosity is too high, the finish will appear bumpy. Like example, say this is a wall on which we applied the paint. So if the viscosity is too high for the paint, then how it will appear on the surface? It will appear on the surface as bumpy, like some parts it's more, some parts less. And if the viscosity is too low, the paint will run, like example, it will have a smooth all around, it will cover. So when the paint is applied on the wall, so all around it will flow. Sid went, what is meant by the viscosity? So what is the definition of a viscosity? Viscosity means property of a fluid. You have to mention this term. Property of a fluid to resist the flow. So when the fluid will resist the flow, that property is known as a viscosity. Before paint is being applied, its viscosity can be checked using a viscosity cup. A viscosity cup has a small hole. As you can see, there's a small opening hole here at the bottom of the for the paint to drain through. The cup is filled with the paint to a fixed level, and a time for the paint to drain from a bottom to a top is measured. Like example, we fill this cup fully and then we record how much time it is taking to flow out from this cup, viscosity cup. Explain why this method can be used to determine the viscosity of a paint. So, and the time for a drain to drain the cup can be converted into viscosity using a table supplied by the paint manufacturer. So why this method can be used to determine the viscosity, or how we can use this? Because the relation with the rate of the flow is inversely proportional to viscosity, or time to flow is inversely proportional to viscosity. If a fluid is having, for time to flow is directly proportional, but rate of the flow is inversely proportional. So how we can use the time to flow is directly proportional to viscosity. If it is more viscous, it will take more time to flow, or rate of the flow. Rate means like how much distance it cover in a unit time, or rate of the flow is inversely proportional to viscosity. If the material is having a high viscosity, it will have a smaller rate of the flow. So using the concept like recording a time for this cup to be empty, using that time interval, we can determine if it and like quickly it empty, it means the viscosity is low. If a time is short, means its viscosity is low. And if it takes longer time, it means the viscosity is high. The time for the paint to drain from the cup was 17 seconds. The flow, following day, the same paint took 24 seconds to drain from the cup. So, like the time for the paint to drain from it was 17 seconds, but then it was taking 24 seconds. Explain why these times are different. Because the viscosity depends on the temperature as well. If the temperature decreases, the viscosity will increase. So on day one, the temperature was high. That's why it was taking a shorter time to flow. But another day, the temperature is low temperature. So the viscosity increased. So the time to flow will also increase. As the time to flow is directly proportional to viscosity and inversely proportional to temperature. So you can mention like the temperature variation is there between the days, and the first day the temperature was high. That's why it was taking a short time to flow. But the next day it was taking 24 seconds. It means that it's become more viscous, so temperature decrease. For a liquid, the temperature decreases with the viscosity in decreases with the temperature. If you increase the temperature, the viscosity will decrease. The viscosity curve is a basic way of measuring the viscosity. Two possible sources of errors with this method and state how these errors would affect the time which we are measuring. So viscosity curve is a very basic method. So what might be the reason for the errors in how it affects the time measure? one thing, like example, the reaction time of a person, because we are using a stopwatch to determine how much time it takes to flow. So reaction time, and as a result, whenever there's a reaction time, the major time is always greater than the actual time. So time will increase. That is one thing. And the second, as you can see, like even the rate of the flow, we assume here the rate of the flow of the fluid which is coming out from the viscosity cup is constant. But in practical, it won't be constant. Why? Because in the beginning, you fill this cup fully with the paint. So there is more liquid inside, more depth of a liquid. So pressure exerted by the liquid depends on its density, gravity, and depth. So in the beginning, there is greater depth of the liquid, so more pressure, the fluid will come out faster, flow faster. But as the amount of the fluid start to decrease, as the amount of fluid start to decrease, the pressure on the base will also decrease. So the rate of the flow will also decrease. So the second thing, the rate of the flow is not constant. And as a result, there are both possibilities are there. It might be greater, it might be small. And another thing that what might happen as a paint is a viscous fluid, so it might block the hole. So if it block the hole, the rate of the flow will change. So it will take longer time. So the point which you can mention here with reference to this viscosity curve, one point you can mention the reaction time, and the major time will be more than the actual time. And the second one, the paint might block the hole at the base of the cup. As a result, the time to flow will also increase. So this was the viscosity, the fluid mainly assignment.